All right, welcome everyone. So I put my iPad in a tripod for a reason. If you were in my class last year, I started recording every lesson and posted it on YouTube and then submitted it, linked it to our Canvas account. Why? Because people loved my class so much they wanted to watch it 6 times at night. Or they got contact traced, or they had a dentist appointment, or. So what it does is it provides the opportunity for students who aren't in class to see and hear what we did in class. By no means do I claim that it is the highest quality video or the most entertaining video you will ever watch in your life. I know that. But it does provide, it serves a purpose. I just got to get it to show up. So what I often do is I'll be pointing at the screen, I'll have it pointing at the board, and then I will post it, whether it's your class or one of my other classes. Then what I'll do within modules for the day, so like today's Friday, today's agenda, what I'm going to do is I'll post it right here. So it'll be linked, it'll also be embedded, so if you need to, it's there. Also, like, you just took the conversion quiz. If you were to click there, it'd get a PDF version of it. So if you aren't here, you can get a copy of what we're doing in class. Maybe you want PDF, maybe you hate paper. It'll be in our agenda. The answer key that I have posted on the back tables on the front board, also linked here. Sometimes, depending upon the day, I'll probably take like some pictures and I'll like for my biology class, I took pictures of what's on the board and I posted those right here, okay? It's just something I did to try to help out as much as I could for those who weren't here. It's not perfect. I'm open for feedback, but that's what it is, okay? So just so you're kind of aware of that. Are there any general questions I can answer about that conversion quiz, I think is what it's called. I'm not going to add, you aren't going to get tested on this material. It's just in labs, we're going to measure centimeters, millimeters, grams, kilograms. We'll be talking meters per second versus miles per hour, and I want you to be able to do those conversions. So it's really just kind of a practice in those types of things. Okay, we're going to start talking about some actual physics stuff today. The physics stuff we're going to start talking about is not new to you, but it's kind of our starting point. It's our stepping stones. So our physics class is kind of broken into different types of motion, or physics, I should say. So we're going to start with something that we generically call this is going to be right in your guys' way, isn't it? Let's go down. This is high quality videography right here. It's called the Davies moving a camera effect. Is that even really clear? We'll see. We'll see. When we start talking, our units are broken down into, our first unit is going to be 1D motion. So we're going to talk about things that are moving left, right, up, down, forward, back, only in 1 dimension. We're going to do a lot of things with that. We're going to talk about acceleration, we're going to talk about velocity, we're going to talk about time, we're going to talk about displacements, and we're going to use equations to go through and figure those things out. We're going to use those ideas for our next unit, which will be 2D motion. So 2D motion is when things do, instead of just going like down, they go in 2 directions, 2 dimensions at the same time. Then we get into forces, which tends to be probably one of the hardest units of the year. And then there's energy, momentum, and we kind of keep going. But that's kind of the first semester and a little bit more. So we're going to start with 1D motion. So in order for us to know or talk about 1D motion, there's a few terms that we need to make sure we have kind of a basic understanding on. And there's these 2 terms that are called scalar and vector. And when we talk about these, what we're talking about is we're talking about quantities or numbers. Okay? So when we talk about a scalar quantity or a scalar number versus a vector quantity or well, we just call it a vector. There's differences, okay? So, when we talk about a scalar quantity, it's nothing more than, it's a number that has a magnitude. It's a number with magnitude. Okay, it's a number that has a magnitude. And when I talk about magnitude, it's just how big. That's all it is. It's a number. Okay, it's simply a number. Magnitude is how big. Okay. So when we get into forces, there's times I'll ask the question like, what is the magnitude of the force? And people will, what's a magnitude force? It's just how big it is. So that's what magnitude is. So a scalar quantity is simply a number that has a magnitude. An earthquake has a magnitude associated with it. We call it a Richter scale, right? We use the Richter scale to measure the magnitude of an earthquake. How much does the earth shake? What we use when we talk about examples of, that's my abbreviation, for example, of scalar quantities that we are going to be dealing with, we have distance, we have time, we have speed. Those are the big ones that we care about at this point in time. Distance, time, and speed. How big? Or how much, right? How much time has passed? A vector quantity it's a number A vector quantity is a number with both direction and magnitude. Okay, so magnitude is simply how big, but when we refer to a vector quantity, we need the how big and a direction. We need the and the direction. So, some examples of a vector quantity. Well, it's not really an example of a vector quantity, but vector, despicable me. Oops, that's the opposite direction I wanted to go. Probably get flagged in my YouTube video for copyright infringement. That's terrible.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Oh yeah! So whenever I say,
check out my new weapon. Piranha gun! Oh yeah! fires, fires live piranhas. Ever seen one before? No, you haven't.
So whenever I say vector quantity, direction and magnitude, we should all join in. This is not going very well in terms of my videography. There we go. You get to see it twice. If that's in your way, sorry, I can move it. But vector committed crime with both direction and magnitude, and that's what we're talking about when we talk about vector quantities. Okay, so instead of talking about distance, for now, we're going to talk about something called displacement. Time, there is no vector like counterpart, but instead of speed, we'll talk velocity. Okay, those are the two kind of the opposites, distance and displacement, speed and velocity. And another big one we're going to deal with, another vector quantity, is acceleration. So distance, velocity, acceleration. Those are the big three we're going to talk about when we talk about 1 and 2D motion. We'll talk about other vectors and scalar quantities throughout the year, but that's kind of where we need to start. So distance versus displacement. I didn't realize my video was so funny. Distance versus displacement. Distance is how far. It's how far did you travel? How far did you drive? It's the question I always think is how far did I go? How far did I travel? How far did I walk? How far did I drive? Where displacement is how far are we from our origin? Okay, so I'll use these as an example. If I start here, and if I take steps and I go 1, 2, 3, you could say, well, how far distance did I walk? And you would all say, you walked 3 steps. Very good. Okay, so that's my distance. Now, if that was my starting point, and this was my end point, we could say, well, what was my displacement? We would say that you are, how far from your starting point? I am 3 steps. And a direction, so 3 steps to the right, and 3 steps to the right. We need a direction, east, west, north, south, plus, minus. We need both, okay? So that worksheet that I gave you called speed problems has, you calculate speed. Speed is nothing more than taking, this is the equation we're going to use, and for now, V average is what we're going to call speed, okay? It's also going to represent velocity in a little bit, but if we use distance, for our for our delta x, and if we use speed for V, and our t is time, if we know 2 out of those 3 variables, we can solve for the other. The units you put in today are going to be the units you get out. So if you have kilometers and hours, your unit would be kilometers per hour. If you had kilometers per hour and hours, you get kilometers. If this is meters and seconds, it'd be meters per second. Miles, hours, miles per hour. Okay? So there's 5 calculations that are all in, it's all just a matter of plugging it into this equation. Okay, the answers for those 5 problems, it's on the back side of the quiz. Okay, they're in the parentheses that are at the very, very end. So for right now, I'm not super concerned about units. We'll get pretty consistent with units as we go on. We will always use meters, we will always use seconds, because our velocities will always be in meters per second. For right now, I'm not that picky, okay? We use the units that we have. So that 5 problem worksheet is to get submitted